So our first step to deciding how atoms are going to be connected together when we're looking at a chemical formula is to determine how many bonds each of the elements that are in the molecule is likely to have. And there's exceptions to this, especially if we're thinking about ions or covalent molecules that have an overall charge. But the rule that works really well in general, again, is that the number of bonds for a molecule will equal, or for an element will equal 8 minus the number of outer electrons. Let's do this for the kind of common elements in that are nonmetals in that second row of the periodic table. We'll use these ones a lot. So carbon. So let's set this up as the equation. So we'll have 8 minus the number of outer electrons. And remember, the easiest way to determine this number of outer electrons is just to look at which column or group the element is in. And so for our main group elements, we have 2 columns, and we have all these transition metals and lanthanide and actinides, and we're ignoring those because they're not main group. And then we have another 6. And so we can kind of count one over. So we'll have 1 outer electron for everything in the first column, 2 outer electrons for our second column. Skip your transition metals. Then we'll have 3 for the column that has boron in it. And boron's a metalloid, so I'm kind of skipping that one for thinking through this exercise and focusing on nonmetals. And then our first nonmetal that comes up next is in the 4th column of the main group elements, and that's going to be carbon. And then we've got 5 and 6 and 7 and then 8. And that's the easy way to kind of get to that number of outer electrons. And they're all the same for every element in that group. So for carbon, it is located in that 4th column. And so it will have 4 outer electrons. And I'm going to use this symbol E with a negative sign. This equals electron. It's my little shorthand way of writing electron, because chemists love to abbreviate things. It's our favorite thing to do, besides blow things up and make crystals and look at pretty color changes. So carbon will be 8 minus 4. We expect carbon will form 4 bonds. All right, let's look at nitrogen. So nitrogen is 1 over on the periodic table from carbon. It is in the 5th group of the main group elements. And so it'll have 5 outer electrons. So we'll subtract 5 from 8. And that'll equal 3 bonds that we expect it to form. We could be also writing the electron dot symbols that we learned about previously. So our carbon has those 4 valence electrons right there, right? Or outer electrons, and it would need to form 4 bonds. Our nitrogen has 5, so it'll look like this for our electron dot symbols. All right, let's do oxygen next. 8 minus, and now it's 1 over from nitrogen. So oxygen is in the 6th main group column. It'll have 6 outer electrons. Sorry about that. So it's likely to form 2 bonds. Let's do fluorine. It's next to oxygen. It has 7. We actually saw an example of it just above. It has 7 outer electrons, so it typically forms 1 bond. All right, let's write our electron dot symbols for these 2. Remember, our electron dot symbols are just the element symbol. And then you take the number of outer electrons and you add them around the 4 sides of the chemical symbol. And then you double them up. And I'd like to show a little correlation right here. Check this out. The number of unpaired electrons that we have, that it's just 1 electron in our element symbol, or electron dot symbol, is equal to the number of bonds that is likely to form. See, we've got 2 for oxygen and 2 unpaired electrons. Similarly, if we look at fluorine, we have 1 unpaired electron, right? And we typically form 1 bond. So I actually tend to just draw my element symbol or my electron dot symbol and look for the number of unpaired electrons. I'm like, oh, that's where I need to form some bonds. I need 1 for fluorine and 2 for oxygen. And it holds for the other ones too. If you look at here's nitrogen has these 3, and it'll typically form 3 bonds. Let's get into the color. Our carbon has 2, 3, 4, and it forms typically 4 bonds. And so I use that a lot to kind of guide, to quickly help me figure out how many bonds to form to something. But this kind of gives the reason for it. Here's a summary table of it as well. And this one is correlating something else. So this one is looking at the number of bonds and then the number of unpaired electrons that it would have. And remember, we have any bonds that aren't going to participate in the sharing of the electrons are going to form as lone pairs, and we'll represent them around our element symbol in our electron dot symbol as just paired up dots. And so those lone pairs are right here. So we've got 1 on nitrogen, we have 2 on oxygen, and if this X was fluorine, we'd have 3, which we could see right here, right? So for fluorine, we've got 1, 2, 3 sets of lone pairs. Or 6 total electrons that are not bonding is another way to look at it. And so again, hydrogen's kind of the exception to the rule because it doesn't follow the octet. But carbon, nitrogen, oxygen, and fluorine, these all follow the octet rule. And you can see that if something has 4 bonds, it'll have 0 lone pairs. But as you decrease the number of lone pair or the number of bonds, you increase the number of lone pairs. And so you could actually take the sum of these and look, they all equal 4. So you could say altogether, we have 4 pairs of lone pairs or bonds. So that kind of bonds plus lone pairs equals 4. And really, this is just kind of another one of these correlations. And these correlations are helpful for kind of double checking yourself when you're building a structure. If you're looking at someone else's, it can help you, noticing these things can help you kind of interpret it a little bit faster and build it a little bit faster.